Welcome back, everyone. Hopefully you're refreshed and ready for some more solving trigonometric equations. Before we do, I just want to recap some notation that we talked about back in Chapter 7, which is if we're talking about powers of a trig function, if we wanted to square tangent of x, so if we wanted to talk about tangent of x whole thing squared, the way that we would normally write that would be to put the square right next to the tangent function. We would write it as tangent squared of x. And then same thing with any other power. So something like secant cube x, what that really means is secant of x, the entire function being cubed. Now, if you don't have the square next to the trig function, so something like this, tangent x squared, it's only the x that's being squared, not the tangent function. So to make that even clearer, you might want to write with brackets tangent of x squared, and that makes it a little bit more obvious. It's only the x that's being squared and not the tangent function. The one exception, of course, to that rule is -1. Tangent with the little -1, we know that that is not a power. This is not the reciprocal of tangent. This is the inverse function for tangent. So for any other number that we put next to our tangent function or sine function or cosine function, those would represent powers. Just the -1 is the only exception. And I'm mentioning that, of course, because we need to be able to solve trig equations where it's not just a trig function, but the trig function might be raised to a power. So here we're looking to solve tangent squared of x -1 equals to 0, which if I just were to rewrite this, we'd say that would be tangent squared of x is equal to +1. And so then tangent of x should be plus or minus the square root of 1. So we have actually two equations to look at now. We have the equation where tangent of x is equal to -1, and also the equation where tangent of x is equal to +1. So when we're solving, we're going to find solutions to both equations. Thinking about my interval again, here we're looking at the interval from 0 to 2 pi. And if we're thinking about this, we're looking for tangent to be -1, which happens in two quadrants, in quadrant 2 and in quadrant 4. We're also looking for tangent to be +1, which happens also in two quadrants, quadrant 1 and quadrant 3. So I should have 4 solutions to this equation. I should have 2 solutions where tangent of the angle gives me +1, and 2 solutions where tangent of the angle gives me -1. Now, of course, nice thing is, since we're looking for tangent to be either equal to +1 or -1, that these should have the same reference angle for both of them. So once we find the reference angle that gives tangent of x equal to +1, that's the same reference angle for where tangent of x would be -1. So let's go back and solve. We're looking to solve where is tangent of x equal to, I'll do +1 first, and so for that, that means that tangent inverse of +1 would be equal to x. And if we're thinking about our special triangles for just a moment here, we know that 1 as a value for tangent shows up for the 90, 45, 45 triangle, whose side lengths are 1, 1, and root of 2, and that it's tangent of 45 that gives us opposite over adjacent 1 over 1, which is just 1. So there is one solution that I can find right away with my special triangles, which is pi over 4. And that's because tangent of pi over 4 is equal to +1. Now for all of my other solutions, I'll find those in quadrants 2 and 3 and 4, and I'll do that with a little bit of a drawing. So let's find the other 3 solutions. In quadrant 2, that would be where tangent is -1. The reference angle is pi over 4, so the angle that we're talking about is 3 pi over 4. So tangent of 3 pi over 4, that would be where tangent is -1. We also have in quadrant 3, where the reference angle is pi over 4, the angle would be 5 pi over 4, and that would be where tangent is +1. And the last one would be in quadrant 4, reference angle pi over 4, which means the angle that we're talking about is 7 pi over 4. And tangent of 7 pi over 4, that should give us a value of -1. So now we've got our 4 solutions. We found that at pi over 4, that would be where tangent is equal to 1. We also found that at 3 pi over 4, tangent has a value of -1. At 5 pi over 4, it's got a value of 1. And at 7 pi over 4, it's got a value of -1. So our solution set is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. That those are the 4 solutions in the interval that we're looking at where tangent would be +1 or -1. Excellent work. Let's continue. We had a similar sort of thing for inverse trigonometric equations where it might not just be the inverse trig function of x, it might be the inverse trig function of some function of x. So we're going to be doing the same sort of thing that we did in the chapter 8.1, which was do a little substitution to make our lives easier. So for example, if you were trying to solve where is sine of 3x equal to 1/2, then you could say, well, I'll just replace 3x with u, in which case you're looking to solve sine of u equals to 1/2. Now, the one problem here, of course, is the business of the interval that we're solving on, because when we change from values of x to values of u, that's also going to affect our interval of solution. So, for example, if you were solving on 0 to 2 pi, and if u were equal to 3x, well, then you could say that x would have to be u divided by 3. So that means the interval that you're really solving on is not from 0 to x to pi to 2 pi. It's that u over 3 is between 0 and 2 pi. In other words, the value of u that you're looking at, multiplying all sides of this inequality by 3, would give me 0 less than equal to u less than equal to 6 pi. So if the original interval for x was between 0 and 2 pi, then the interval for u would be between 0 and 6 pi. So not 1 full circle, but now 3 full circles. And we'll have to do that anytime we carry out one of these substitutions, because if we substitute in for x, if we replace it with our function of x, if we replace it with u, that will affect our interval for solutions. And the other part to keep in mind here, of course, is that at the very end of it all, yes, you found values for u, but you'll still need to go back and find values for x. So that means once you find your solutions are u is this number, that number, whatever those numbers happen to be, then you'd have to go back and say, oh, 3x is equal to this number, that number, next number, and then you can solve for x by dividing everybody by 3. So let's do an example. This is something where this is a fairly involved kind of a question, but let's do one from start to finish. Here we're looking for sine of 3x equals to 1/2 on our interval from 0 to 2 pi. So the first part, of course, is we are going to be letting u replace that 3x, or in other words, that means that x is the same thing as u divided by 3. So as far as the interval goes, 0 less than equal to x less than equal to 2 pi becomes 0 less than equal to u over 3 less than equal to 2 pi. So in other words, we're going to be solving over the interval from 6 pi down to 0. So we'll be solving over this interval, and the equation that we'll be solving, instead of sine of 3x equals to 1/2, since we're replacing 3x with u, then we'll be solving sine of u equals to 1/2 on that interval from 0 to 6 pi. Now, one thing to think about here, of course, is again quadrants, and we're going to think about that just before we do any solving. Here, the quadrants that we're looking at will be quadrants where sine has a positive value. And sine is positive. We're looking for where is sine equal to a half. It's positive in quadrant 1, and it's positive in quadrant 2. Now, if we were just solving between 0 and 2 pi, then we would get two solutions. There'd be one in quadrant 1 and one in quadrant 2. But we're solving between 0 and 6 pi over 3 full circles. So in one full circle, there'll be two solutions. And then in the second full circle, there'll be two more solutions. And in the third full circle, there'll be two more solutions. There should be 6 solutions in total, because as we make our way to 2 pi, to 4 pi, and to 6 pi, we've crossed through quadrants 1 and 2 3 times. Now, the nice thing is, of course, is that for the values of u that we're looking for, the value that we find in quadrant 1 the first time and the one that we find when we pass through it the second time, those two values will differ by a full circle. They will just be 2 pi apart from each other. They'll be coterminal angles, essentially. So we will start out by finding where are the angles within one full circle, and then we know that we're looking actually for angles within 3 full circles. So the other 4 solutions that we'll find, those will just be the other angles that are coterminal to the ones that we've found. So let's start off with the first part, finding solutions within 0 to 2 pi within that first full circle. Just going to quickly jot down my special triangle. So I know that this is the 30, 60, 90 triangle, and I know from my special triangle that sine of pi over 6 is opposite over hypotenuse. Sine of pi over 6 is a half. And that's the first angle that I'll have is pi over 6. Remember that we'll be looking for angles that are in quadrant 1 or quadrant 2, and we've found an angle in quadrant 1, which is pi over 6. So another one, the one that would be in quadrant 2, would also have the same reference angle of pi over 6. So that would be the angle 5 pi over 6. So sine of 5 pi over 6 should also be equal to a half. Now, for the other 4 solutions, I'll find by taking these 2 solutions and adding on full circles. So the value of u that I'm looking for, so far I have 2 solutions, pi over 6 and 5 pi over 6. And then the next 2 solutions I'll find by going ahead by 2 pi, by going one full circle forward for both of those angles. That will give me angles that are between 2 pi and 4 pi. And then once I've done that, so let's do that. Let's go forward a full circle. Pi over 6, if I take this number and I add on 2 pi, so pi over 6 plus 2 pi, that is 13 pi over 6. 5 pi over 6 plus 2 pi, that is 17 pi over 6. Okay, so I've now got angles within 2 full circles, and for the third full circle, I again will need to add on another 2 pi. So going forward for both of these angles, one more full circle. So 13 pi over 6 plus another full circle, that's 25 pi over 6. And 17 pi over 6 going forward a full circle, that is 29 pi over 6. Now, those are our angles in terms of u, but of course that's not the answer that we're looking for. We're looking for angles in terms of x, and this is where we go back and remind ourselves that u is the same thing as 3x. So that means that instead of saying u is equal to all of those angles, I can say that 3x is equal to all of those angles. 3x is pi over 6, 5 pi over 6, 13 pi over 6, 17 pi over 6, 25 pi over 6, and 29 pi over 6. And of course, if I wanted to solve for x, which is what I'd like to do, then that means I need to divide everybody by 3. So dividing all of those numbers by 3 tells me that x should be pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25 pi over 18, and 29 pi over 18. And so those 6 solutions, those will be the answers that I'll put in my solution set. So pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25 pi over 18, and 29 pi over 18. Wonderful. So I'm just going to recap this before we do one more example. So again, we were looking to solve sine of 3x is equal to a half. So first thing that we did was to do a little substitution, replacing 3x with u. And that meant if 3x was equal to u, then x is equal to u over 3. We then used that to be able to figure out what our interval should be for our solutions in terms of u. So we were looking for, instead of x to be between 0 and 2 pi, we're looking for u to be between 0 and 6 pi. Then we just think about our quadrants as usual. We're looking for sine of u to be equal to a half, which is positive. That was in quadrants 1 and 2. We know that we're looking for over 3 full circles, which means that we're going to go through each of those quadrants 3 times. There's going to be 3 answers in each of quadrant 1 and quadrant 2. So we know that we'll find 6 different values for u. I used my special triangles to find one of those values, and then once I knew that reference angle, I found another value. So I found pi over 6 and 5 pi over 6, and I know that the other 4 solutions, the ones that are full circles away from that, I can find by adding on full circles, by adding on 2 pi. That from pi over 6 going forward a full circle brings me to 13 pi over 6, and going forward a full circle again brought me to 25 pi over 6. 5 pi over 6 going forward a full circle, going forward a full circle again, that got me my other solutions. Once I knew what my solutions were for u, then I said, well, u is the same thing as 3x. And I used that to solve for x by dividing everybody by 3. So then I have now my solution set, and I am finished. Let's do one last example. This one is even more involved. Here the substitution is going to be even larger or even more complicated than the one before. Before it was just sine of 3x. Now this is cosine of 3x plus pi over 2. So the substitution that I'll do here will be to let u replace 3x plus pi over 2, which if you were to rewrite this in terms of x's, that would be saying that u minus pi over 2 is equal to 3x. And if we divided everybody by 3, that would be 1/3 u minus pi over 6 is equal to x. And the reason I'm doing this is because I'm going to need to use this relationship to rewrite my interval, because the interval right now that we were given from 0 to 2 pi, that's in terms of x, but we need the interval to be rewritten in terms of u. So instead of saying from 0 up to 2 pi for x, then we can say 0 up to 2 pi for 1/3 u minus pi over 6. So this is a fun flashback to the very beginning of the course. We're basically manipulating an inequality. I will add pi over 6 to every side of this inequality. So 0 plus pi over 6, that's pi over 6. In the middle, adding on pi over 6 gets rid of that negative pi over 6. And 2 pi plus pi over 6 is, there we go, 13 pi over 6. All right, so now to solve for u, to find u isolated by itself in the middle, I take all sides of that inequality and multiply everybody by 3. Pi over 6 times 3 gives me pi over 2. A third u times 3 gives me u. And 13 pi over 6 times 3 gives me 13 pi over 2. So 13 pi over 2, that's the same thing as 6 pi plus pi over 2, or 3 full circles plus pi over 2. So if we're thinking about our interval that we're solving on for u, then we're really looking at starting at pi over 2 and going 3 full circles around. And if we're thinking about that, we know one full circle, 2 full circles, and 3 full circles. And right where I stopped there, that is 13 pi over 2. Same thing as before. Notice that I've got 3 times that I pass through each of my quadrants. Every quadrant I pass through it exactly 3 times, which means I'm going to find multiple solutions in each quadrant. Okay, so let's get ready to solve this. And so now I'm going to take my equation and I'll actually do that substitution. We're replacing the inside with u, so we have 2 cosine of u plus root 3 equal to 0. And if we isolate the cosine function, moving the root 3 over to the other side and dividing by 2, we get cosine of u equals to negative root 3 over 2. Okay, so let's do some solving. We're looking for cosine to be negative, and so we know if we're thinking in terms of quadrants, cosine is positive in quadrants 1 and 4, and it's negative in quadrants 2 and 3. And we also know we were going to pass through quadrant 2 and 3 times. So I'll first find solutions in quadrant 2 and 3, and then the other solutions I'll find, there'll be 6 of them in total, by going a full circle ahead and then another full circle ahead. Now, we're looking for cosine of u to be negative root 3 over 2. And root 3 over 2, again, we'll remember that hopefully from our special triangle, the 30, 60, 90 triangle. You know from this triangle that if you're looking for root 3 over 2, that happens for cosine of pi over 6. That cosine of pi over 6, that would give me positive root 3 over 2. And so the two angles that we're looking for are not pi over 6. That would be the angle that's in quadrant 1 where cosine is positive. We're looking for angles in quadrant 2 and 3 where cosine is negative. In quadrant 2, if you had a reference angle of pi over 6, then the angle would be 5 pi over 6. So that's one of our solutions. And if you were in quadrant 3 and your reference angle was pi over 6, then u would be the angle 7 pi over 6, and that would be another solution. So we have two solutions so far. One solution would be 5 pi over 6. That would be something where cos is negative root 3 over 2. 7 pi over 6 would also be a number where cosine is negative root 3 over 2. So now we'll do the same sort of thing that we did before and say, well, now that we've found these two solutions, one solution in quadrant 2 and one solution in quadrant 3, the other solutions I'll find by going forward one full circle, adding 2 pi, and going forward a full circle again, adding another 2 pi. So let's do that. We'll say that we had that u was supposed to be 5 pi over 6 or 7 pi over 6. If I go forward one full circle, if I add 2 pi to both of those, 5 pi over 6 plus a full circle is 17 pi over 6. If I take 7 pi over 6 and go forward a full circle, that's 19 pi over 6. 17 pi over 6, go forward a full circle from that, that's 29 pi over 6. 19 pi over 6, go forward a full circle, that is 31 pi over 6. So we have the angle 5 pi over 6, 17 pi over 6, and 29 pi over 6. Those are all coterminal to each other. Those are all in quadrant 2, and all of those angles are ones where cos of any of those would be negative root 3 over 2. We had 7 pi over 6. We went forward a full circle, added 2 pi. We added 2 pi again. So those three angles, 7 pi over 6, 19 pi over 6, 31 pi over 6, they would all give us the same value for cosine of negative root 3 over 2. So we have found for the original equation that we were solving, or sorry, the original substitution that we were solving, where is cosine of u equal to negative root 3 over 2, we have found the 6 values for u. Now that we know the 6 values for u, now we're going to go backwards and use the relationship between u and x to find out what those angles are in terms of x, to find out what are our solutions in terms of x. So now we'll use the fact that u is the same thing as 3x plus pi over 2. So we can say that 3x plus pi over 2 is equal to all of those angles. 5 pi over 6, 7 pi over 6, 17 pi over 6, 19 pi over 6, 29 pi over 6, and 31 pi over 6. And now just to solve, of course, if I want to solve for x, then I guess next thing for me to do would be to subtract pi over 2 from everyone. So to get rid of that plus pi over 2, I will subtract pi over 2 from all of my numbers that I have here. So I can say that 3x should be equal to 5 pi over 6 when you subtract pi over 2. 5/6 minus 1/2 is a third, so we would get pi over 3. 7 pi over 6 minus pi over 2 is 2 pi over 3. 17 pi over 6 minus pi over 2, that's 7 pi over 3. 19 pi over 6 minus pi over 2, that's 8 pi over 3. And 29 pi over 6 minus pi over 2, that's 13 pi over 3. And last one, 31 pi over 6 minus pi over 2, that's 14 pi over 3. Reminder again that when you're doing these little calculations, if you're trying to figure out what is 31 pi over 6 minus pi over 2, you could sort of ignore the pi's for now and just think 31 over 6 minus 1/2. And when I used my calculator using the fraction function, 31 over 6 minus 1 over 2 gave me 14 over 3. So in other words, 14 pi over 3 should be what I get when I take 31 pi over 6 and subtract pi over 2. And then last thing that I need to do is just to divide everybody by 3. So then dividing everybody by 3 will allow me to solve for x. So x is pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, and 13 pi over 9, and 14 pi over 9. So we now have our 6 solutions, and you can check that these 6 solutions we have are indeed in the interval for x. Remember that the interval for x was supposed to be angles between 0 and 2 pi, and between 0 and 2 pi, these numbers, yes, they all are. 2 pi is the same thing as 18 pi over 9, so we're definitely less than 2 pi, and we're certainly more than 0, so these are all solutions in the interval for x that we were looking for. So we can now just say that our solution set is pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, 13 pi over 9, and 14 pi over 9. And that would be the solution set for our equation that we were solving. Excellent work, everyone. So we'll have one last break, and when we come back, we'll talk about solving trigonometric equations where instead of solving it over some limited interval, we'll be solving it for all real numbers. So not just over one full circle, but we'll be solving over from negative infinity to infinity. So for these equations, they should be having infinitely many solutions, and we'll talk about how to express that. All right, we'll see everybody shortly.